Since you're the only person I gave the link to, I'm going to assume that's you, Sander. I'll just assume it's you. Okay. I'm only going to go. Oh, hello. I'm only going to go through one question because you'll love this. It's got two parts. Where's my mouse gone? It's got two parts, but the second part's got two parts. And the first part, 20% or something of students got it correct. And then the second part, there was just, yeah, it always does that. It always says there's one person, like one extra person. And then this second part, only 3% of people got that right. And then this second part, only 2% of people got that right. So, and it's also got a dash next to extension 1, so I'm assuming that it was either, like it must have used to have been an extension 2 question, but all of this stuff's always been extension 1, so I'm thinking it must have been in that. There used to be an extension 2 topic that was like harder extension 1, so I'm assuming this is considered a harder extension 1 concept. Anyway, so let's go through this thing. I'm only going to go through this because I want to go through it in some detail, and there's a couple of pictures that I want to draw, and I practiced them so that they weren't terrible. But I think the hardest part about this question is it's not immediately obvious how the first picture and the second picture relate to each other. I mean, it might be, but it certainly wasn't to me when I was first doing it, because it's just a strange question, but it's clever, just strange. So, sorry. There's a circle, so obviously this circle, it's got a radius, center, circle meets at the positive axis at point B, so it's just saying this is the circle. And then it makes this interval where the line OB, the vertical line A through A, so this line here is just blah, 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 it's just describing this picture. No one cares about that. Now it's saying the shaded region bounded by the arc PB, so this, and the intervals A, B, and AP, so A, B, and AP, so it's basically saying the shaded area is rotated about the x-axis. So you imagine it's rotated this way. Now, what that kind of looks like is like a hemisphere, but not a sphere, if that makes sense. So like this thing, like that. So it's like this, if that kind of makes sense. That was a terrible picture. Anyway, show that the volume is this thing. So basically we need to rotate this area around the x-axis, but we're not given enough information. Like you're not told what this point is, you're not told what this point is. So I just kind of thought to start, let's just do it. I need an extra page. Okay, so question 20. Okay, so should I just draw that? That O, A, B, P. There's another line there. Theta R shaded X, Y. Okay, what are you thinking so far? Because this is kind of strange. Anyway, so the goal would be to integrate. So I'm going to find the volume, chuck a pi up front, goes from A to B. So I'm just going to call them that for a second, even though it's a little bit weird. If you're not going to give the information, I'll assume they cancel out. If you're not given the information, you'd assume they cancel out. Yeah, maybe. Okay, so we're trying to go from B to A. So like I want this X distance here. Now, you can't really describe this thing in terms of like two coordinates. That doesn't really make any sense. So the first thing you might identify is that this distance here, That's another way of saying the radius. So I've got obviously two things for the radius. So many notifications. Okay, so then in order to find BA, so like this, so like I need B. Well, B's easy, it's R. I need to find this distance here, so it goes from this to this, if that makes sense. So I kind of want to know what this point is. So there's a bunch of information that I'm not really given. Also, this will be y squared dx. Okay, so let's go over the three pieces of information that I don't have. The first one's A. So this A value here. Now, if I wanted to find that, there's not really much I can do. Like if I need this distance, let's call this A. That's kind of what I need. Now, the only way I'm going to get that is from like this triangle here. So I've got theta, I've got R. So then let's go with, that's opposite and hypotenuse, so sine. So I'm going to have sine theta equals A over R, which means A is equal to R sine theta. So that can be another way of writing R. Trig, yeah, nice. Okay, so let's continue with that. So then I've got A was R sine theta. And you can see that that's nice because my show that question has a bunch of sine thetas in it. And then if I wanted to find the B, that's pretty easy. That's just R. So that's just R, which was the radius. That's going to be in my way. I feel like there's a lot of this question has got to just do with like interpreting it. Okay, and then this y squared, that's kind of easy because my function over this point, this arc, is just the equation of a circle. So I've got x squared plus y squared equals r squared. And then if I want to get y squared by itself, that's just r squared minus x squared. So that's easy. So now I have everything. So this b value up here is r. My y squared is just r squared minus x squared dx. And then I have an expression. And so I've got this expression for my integral. And supposedly, that should lead me towards this thing here. So that's the goal. Oh, can I highlight? How do I do that? Anyway, let's not focus on that. Okay, so if I just go from here, pi outside of. Now, apparently, this was written in the notes, the most common mistake in this part was not recognizing that you need to integrate with respect to x. And people were going, oh, okay, well, I've got this r squared, so that must be 1/3 r cubed. But that's just a constant, like that's just a value. So that's just r squared x minus 1/3 x cubed. So apparently that was a huge mistake between r sine theta and r. What do you think about the presentation as well while I'm working through this? Okay, so then that's r squared r minus 1/3 r cubed minus r squared r sine theta minus 1/3 r cubed sine cubed theta. So then that's, whoops, pi r cubed. Hang on, r cubed minus 1/3 r cubed is 2/3 r cubed minus r cubed sine theta minus, no, plus 1/3 r cubed sine cubed theta. I didn't really see how it was different to what you were doing anyway. Yeah, I thought the same thing, especially when he had the exact same question as me. I was like, yeah, this is kind of like the same thing. Oh well. Yeah, he seemed really smart, so that was kind of cool. And it was cool that he just kind of went through the exam, like just off the top of his head. Okay, what was I doing? So I'm aiming for this thing. So I need to bring out I've already got the pi out, so I need an r cubed and 1/3 out. So pi r cubed on 3. So what does that leave me? That leaves me with a 2 there. I've taken an on 3 out, so that means a 3 needs to be there. The r cube's gone, so that's just sine theta. I've taken the 1/3 r cubed out, so that's just plus sine cubed theta. Is that what I want? Yep, as required. Nice. Okay, so this is obviously the part where nobody got any marks. Well, if you count 2%, as a lot of people, which is not. So it's just really weird to interpret. Like, I just think it's really strange. Let me zoom in on it. So a container is in the shape of a hemisphere. The container is initially horizontal and full of water. Then it's tilted at an angle, so then some water spills out. So it's basically saying the original is this shape. So the original's hemisphere, so a hemisphere like this, but it's full of water. And then what they've done is they've rotated it this way. So now it's like angled like this. So you imagine this picture is just this picture sideways. And then water's just kind of come out of it, if that kind of makes sense. It's such a strange concept, I guess. Apparently the worst part about this question was setting it up. So now I have prepared this question and I've drawn some immaculate pictures, but the pictures I'm about to do on the fly aren't going to be. Anyway, okay, so the question wants the depth of water, find theta, so the depth of water remaining is a half of the original. So the depth of water is half of the original. So I'm going to draw two pictures. I'm going to draw what the depth of the water would normally look like and what the original would have looked like. So the depth of water is going to be kind of like the picture that they give you. So I'm going to try and copy that and then add to it, essentially. So it's got that round part there, and then it goes like, oh, mine looks like an egg already. And then it goes like this. Yeah. And then that part in there is theta. What annoyed me yesterday, the other day, was when he was trying to draw using his mouse. Anyway, and then that is the part that's full of water. This is a terrible picture. Can it be like, oh well, it looks like an egg. Is that all the piece of, yeah, okay. So then I'm going to add to it. So it's actually almost identical to this top picture up here. So you think of this part here as the part that's full of water, and then this whole part is the whole container. So then you've got like this whole container here, then this part that's just full of water. So that was the point of doing the first part. So you can see that it's the same. And then this angle is this angle here. And so then the whole thing's been kind of tilted. So that's how we've got this three-dimensional strange picture. But I don't think the link between the two ideas is like kind of obvious. Okay, so then if we're referring it to the old picture, then you've got the points, that was the origin, and then that was A and that was B. So if you look back at this, you've got the origin, which was the outside of the angle here. Then you've got A, which is the other part of the angle, so like this triangle here. And then you've got B, which is where the water kind of ends, so B, so it's kind of sideways, if that makes sense. So then using the pieces of information we had before, that's R, so that there is R, and then OA, so that was what we found out last time, was R sine theta. Okay, so then the depth of the water is going to be, so this part, that's going to be the depth of the water, so this distance here, which is going to be R minus R sine theta, if that makes sense. So that's like all of this minus this is going to give us this, which is this minus this, which is R sine theta. I hope that kind of makes sense. Let's bring that there. So then that's an expression for the depth of the water. So R minus R sine theta. You can see why this would be a terrible question, like confusing for the students, especially given it would have been the last question. So also considering that only 2% of people got it, you could probably argue that this is the hardest question ever asked in Extension 1. Anyway, all right, what are we doing? Now I want the original. So I'll draw a picture of the original, which would have looked like this. Okay, so then that length there is just straight up R, if that makes sense. So then if you think about, yeah, well, I guess that's it. So because it's depth, it's just looking for a value for the height. So the value for the height is this, and the value for the height is this. I don't care about like volume or anything like that. So I'm just talking about depth. So then that's that. And so now really all I have to do is solve for theta, which doesn't seem too hard. I can just kind of cancel a bunch of stuff. So if I just factorize this 1 minus sine theta out, that allows me to get rid of the r's. Equals a half. And then if I go 1 minus a half equals sine theta, that's a half equals sine theta. So that means theta equals pi on 6 or 30 degrees. What does it want it in? Doesn't say anything about radians or degrees, just says theta. So one of those. If that makes sense. But it's just a weird concept. Like, that should be full of water. Picture's not bad. Let's agree on that, surely. I'm running out of space here. Hope that kind of makes sense. Is there anything you want to say about that? So I don't want to go to question 2 was worse in terms of how many students got it. On another page. II2. Pretty quick at this stage. It's only been 16 minutes. Okay, so it wants what fraction of the original volume is left in the container. So this time it's asking about volume, whereas before it was asking about depth. So the original volume, and you think about in terms of the original picture. That's the original. That's the new. So you think about the original picture. It's literally a hemisphere, and it's told us that it's a hemisphere. It said that in the question. Did it? Yeah, container-shaped hemisphere. So the original thing is literally just the equation of a hemisphere, which is so equals hemisphere, which is literally half a sphere, which is half 4 on 3 pi r cubed, which is the 4 and the 2 cancel. That's 2 on 3 pi r cubed. So that's an expression for the original volume. And then it says what fraction of the original volume is left in the container. So it hasn't said, like it's kind of implying that it's relying on the last question, because it hasn't said like for this value of theta or anything like that. It's just said, well, find theta and then tell me what fraction is left. So it's kind of backing off the last part. Yeah, nice. 2 and 3 pi. Yeah. So I think it's worded a little bit, controversially, because it hasn't, like, it should maybe say at the same theta what fraction of the original, because it doesn't really make that clear. I don't know if that's clear or not. Maybe that's just me, but I feel like that's not too clear. Anyway, so that's the original volume. So the new volume. So basically, if we want a fraction of the original volume, it's going to be this over this. So how much is left over what we originally had. So the new volume is what we proved in the first question. So we actually, I think this is one of the harder parts, is identifying that we actually have already done that, because by rotating, so we consider that a part of our hemisphere, by rotating this around, we actually found this volume previously, and we haven't actually used that piece of information. We've just had to show that question and then not used it. So I don't know. Do you think that's obvious, like the link between the two-dimensional picture and the three-dimensional picture? Like, do you think that's obvious? Because I don't know. Maybe it is, maybe it's not, maybe it's just me, but I think it's not that obvious, and I think it could have been made a little bit clearer. I don't know, but anyway, we already have a volume for the amount of water, because that's the amount of water. We already have that. That's this thing. So what was it? Pi r cubed. Is it pi r cubed on 3, 2 minus 3 sine theta plus sine cubed theta. Sine cubed theta. Now that's an expression for any theta, but we were saying before that our value for theta is given or implied from the previous question. So when theta was, we're using 30 or pi on 6? I don't really care. Let's use pi on 6. That implies the volume is, now pi, we don't ever know what r is. 2 minus, okay, 3 sine pi on 6 is just a half, so that's that. And that's going to be a half cubed, 1/2 cubed. Okay, so that's going to be pi r cubed on 3. Okay, what the hell? 2 minus 3 on 2 plus 1 on 8, 5 on 8. Okay, so then 5 pi r cubed on 24. I don't think it would be obvious if it wasn't in the same question, but because the question was another part of the proof question. Yeah, yeah, maybe. Yeah, you're right. If it was separate, then yeah. I don't know, it's just for me, this picture's like, it's like backwards, you know, like this is, if they just rotated that, I understand why it's faced that way, because then it looks like there's no water spilling. But if they'd drawn it that way, then it would match this picture a little bit better. Look, I don't know. They have used, maybe if they put R, maybe if they put O, A, and B on, maybe that's why it's a hard, like your question 10 or something. Maybe that was the intention, for it to target the kids that are a little bit smarter. I don't know. Anyway, okay, so the fraction would be the new volume over the original volume. So the what's the new one? 5 pi r cubed on 24 on 2 on 3 pi r cubed. Okay, let's deal with this. You can go, you can go. So we've got 5 on 24 on 2 on 3. I hate when fractions are like that. 5 on 24 times 3 on 2. That's 15 on 48. Surely there's a common factor in there. 15. Yeah, 5 on 16. What's the thing? Oh, 3. Yeah, right. 5 on 16. Because you have to rotate the hemisphere back to level to get the 2D diagram. Yeah, exactly. Yeah. Yeah, maybe that's the confusing part, because that looks like it's been rotated, and then the water's, like if that hadn't been rotated, the water would be sitting. Let me go to my original picture. Oh, that's so bad. If it hadn't been rotated, the water would be sitting like this, yeah? That's what you're saying. So the water would be like that, which isn't realistic, because obviously water is affected by the laws of physics. So that's why it's sitting like that. So then, yeah, because then the picture, if they were to do the picture like that, then it would look like that. And we don't have the tools to be able to find, I mean, we don't have circle geometry. Maybe that would be a circle geometry question then, but we don't have the ability to find that volume wrapped around, or do we? Wouldn't that just be the integral of that minus whatever that is? Would that just be a much harder question? How many marks is this? Wow, the first part was 3 marks. Okay, so all that was 3 marks. How interesting. I wonder where the marks would go. And then this thing is only 1 mark, this whole thing here. Like the interpretation of the picture. And then, but then this was 2 marks. So maybe that's man, 6 marks for, I don't know if that, is that fair, you reckon? Like, I don't know. Anyway, but the first question basically is like, where is it? It says that at that angle, the depth is half of what it is, and then the actual volume at that depth is 5/16 of that, which is kind of interesting. That's criminal mark distribution. Yeah. Yeah, what do you reckon? I don't think the first part's that hard. I don't think that's the hardest part of the question, and it's worth 3 marks. Especially because it said, look, I'll show you. Where is it? We've only got 3 questions left. Here it is. Volume. Yeah, so look at this. It said the common error was to integrate, so that was what I was saying at this point. It was to integrate that as a third r cubed. And then look at this. So part II was the hardest mark to get, so 3% and 2% for these. but it was extension. It doesn't say what exam it was in. Like, I'm pretty sure that dash means it's in extension 2. 2010 extension 2 maths. 2010 extension 2 math. Question 10b. That's 5. Oh, what? Did they not have multiple choice back then? Hey, look at that. These never used to have multiple choice. I did not know that. Wow, that looks... Anyway. Does this even have 10 questions? No. It must have been extension 1 then. Can't have been advanced. That'd be ridiculous. Where is this question? 2010. Just 2 unit? Surely not. Maybe that's why, because I feel like it's not that hard of a question. Maybe that's why so many people got it wrong, because it was only an advanced question. Wow, it was an advanced question, Xander. Wow. We do volume rotations in is that an advancing? Or was that extension? Did we do that in extension? I don't remember. Wow, that's advanced. No wonder it was so that makes so much more sense. Okay, so that means the asterisk means advanced, and the dash meant extension 2. Wow. Yeah, that's really mean. That's a that's a heaps mean question. Can you imagine giving that to our advanced class? Wow. Didn't see that coming, hey. What else did advanced have back in the day? I can't believe that. That's it does make sense now why it was only 3% and 2%. Let's see where the marks went. Can we do that? They're the simple answers. It's exchange. Yeah. Okay. What? Oh, there's the question. Oh, look at that. How did they get that so fast? 1 mark. What? The depth of the water is half the original. Oh, what the heck? Go back to the question. I'm just looking at how they got that answer so fast. Like 2 lines working. Okay, so that's sideways. Half the original. That's interesting. Wow, okay, yeah, right. We have some marking guidelines. Here we go, here we go. This is the juicy stuff. Why does it say question 28? Oh, general maths. Okay. Wait. Cosine rule. Oh, these ones. Okay. Obtains that. All right. So the first mark goes from. Oh, obtaining. Oh, that's how I wrote it. That's cool. Okay. So the first mark goes from obtaining that. The second mark comes from obtaining that, and then finishing it off. Correct value for theta, or obtain sine theta equals a half. Oh, so you didn't even have to finish that question off. As long as you got to, if you got to there, I mean, if you got to there, you could obviously just, be pretty easy to finish it off. Interesting. Okay, well, that's 1 mark. Attempts to substitute sine theta equals a half, or they answer from part 2 into V. So, into V. Okay, so making this substitution into there gives you a mark. Okay, so that's a recognition of the link between these two questions. Okay, is that it? And then what was the second mark for? Just the correct solution. Yeah, right. What do you think about that? I still can't believe that that's an advanced question, but but yeah, it makes sense why that was only 3%. No, so I can't believe that. All right, I think we've rambled about this question long enough. Yeah, so we've only got. Have we got my MB? We've only got these 3 questions left, and then we're done. And we've answered every Band 6 question ever asked in Extension 1, even though that was advanced. So that was a Band 6 advanced question. Okay. The only yeah, okay. And have a look, they're all combinatorics. Ah, my favorite. Not. Oh, they're so wordy. Yeah, it used to be. It was when I did it. I did mine in 2013. So it was in there back then. I'm not sure if it's only one way or not. I think it was only because you know how you rotate around this way and that way. I can't remember. I have to get my maths book out. This was the textbook I used though. Look at this thing. It's not even got colors. It's all like black and white, and the pages are like yellow. Oh, let's actually find it. This has been written in. That's great. There's calculus. I don't know. It's in here somewhere. Integration. Volumes of solids or revolution. Yeah. Yep. Wow. Yeah, there's your solids. There's phases. Anyway, that was fun. Did I do extension 2? No, I didn't. There wasn't. My cohort was really low. There wasn't a 5.3 class in my year, so our class was 5.2, and then only 9 of us did advanced, and only 2 people wanted to do extension 1, so that didn't even run. So extension 1 didn't even run at my school. So therefore extension 2 didn't run either. So yeah. Yeah, I wasn't part of a very smart cohort, or a smart school for that matter. Anyway. All right, I have to go. I have a meeting. But yeah, we'll do these 2 next Tuesday, and then we can do this next Thursday if you like, and then we're done. Then either I can go through Cambridge questions, or I could find all by Band 5 questions, or I don't know. You want to? Yeah, I did want to do it. There was only two of us, but yeah, they couldn't run it with two people, which is why it's kind of lucky we can. Well, you can these days. But yeah, I don't know why they didn't run it. Maybe they didn't think we were good enough. It's probably warranted. Um, yeah, because we went into advanced and we hadn't done like 5.3 content, so I didn't know what a surd was, and I didn't know what a polynomial was and stuff like that. So it kind of made sense that they didn't let us do extension one because yeah, I didn't know what a square root was. So that's kind of sad to be honest. But you know, anyway, anyway, all right, let's leave it at that. I'll see you next week. Have a good weekend. Is that everything? Yeah, I'll upload this now.